15 trigonometric functions. All right, guys, ready? You ready? If you guys want to shift a trigonometric function, you must know what the mother functions look like. And to do the mother functions for trig, you guys got to recognize the patterns. And so we're going to start off with sine. So here we have a function. It's y equals sine x. And what we're going to do is we're going to graph this on an xy plane. And we're only going to graph one period. So guys, do you know when sine values start repeating themselves? Like from what are, no, that's not a good question. No, that is a good question. When do sine values start repeating themselves on the unit circle? After 2 pi, after you complete one full rotation. So 2 pi is where we're going to stop. We're going to start at 0, we're going to end at 2 pi. And what we're going to do is we're going to divide up 2 pi into 4 chunks. So we're going to divide 2 pi by 4, and when we do that, we get pi over 2. You guys know what pi over 2 is, right? You're familiar with pi over 2. So we're going to divide this up into 4 chunks. We're going to do 0 pi over 2, and then 2 pi over 2, and then 3 pi over 2, and then of course we would get 4 pi over 2, which is the same as 2 pi. So we don't need to write that. We can simplify that, and this actually simplifies also to pi. All right, so now, if we want to graph sine x, you guys need to think of what values on the unit circle. On the unit circle, you guys got the radians, you guys got the x, you got the y values, the x and the y values. Which values are we looking at for the unit circle? On the unit circle for sine. Which one? Which one? The y values. Very good. I mean, man, you're so intelligent, Ann. Okay, look at your unit circle, guys. Look at 0 radians. What is the y value at 0 radians? You guys are looking at unit circle, right? It is 0. So we're going to put a dot right there at 0, 0. Now look at pi over 2. What is your y value at pi over 2? It is uno. So we're going to put a dot right up there at uno. And then we're going to hop over here to pi. That's halfway around our circle. What are the coordinates, or the y coordinates for that one? 0. Okay. And then what about for 3 pi over 2? -1. All right, so we're going to put a dot right there. And then 2 pi, what's the y value? Back to 0. So there you have it. There is your sine function. The other mother function that I want to talk about is cosine. So we're going to go cosine of x, y equals cosine of x. And I want to graph the general form, the mother function for cosine. And I just want to go one period, just like sine. So we're only going to go from 0 to 2 pi. And it's going to look this exact same as what we just did. So we don't have to divide it all up like we did before. But we do have to look at different values on the unit circle. So when you guys are looking at the unit circle for 0 radians, what value are you guys looking at? You're looking at the 1 because that's x, right? Look at the x values. So I'm going to start right here at 1. Okay, now if I go over to pi over 2, what's our x value at pi over 2? 0. What's our x value at pi? -1. What's our x value at 3 pi over 2? Okay, 0. And then finally at 2 pi, it's uno. So this is what your function looks like. Isn't that interesting? They actually are almost the same functions, but what makes them different? Yeah, it's a little shifted over. Like I could take sine and I can shift it over a little bit. I can shift it over pi over 2, and then it'll look just like cosine. Or for cosine, I could shift that one over to the right, pi over 2, and it'll look just like sine. So you guys got to know these. You guys got to know how to graph these mother functions, because we're going to use those when we start shifting these trigonometric functions.